In this example, we want to find solutions to the logarithmic equation log base 3 of x plus 6 minus log base 3 of x plus 2 equals log base 3 of x. To solve this equation, we will need to use our properties of the logarithm. In particular, we can combine the two terms on the left-hand side using the property that log of x divided by y equals log of x minus log of y. This allows us to simplify the left-hand side as log of x plus 6 minus log of x plus 2 equals log of x plus 6 divided by x plus 2. And remember, we still have log of x on the right-hand side. So we're now left with the equation log base 3 of x plus 6 divided by x plus 2 equals log base 3 of x. Now since log base 3 is a one-to-one function with inverse 3 to the x, we can undo the logarithm on each side by raising 3 to that power, which gives us the equation 3 to the log base 3 of x plus 6 divided by x plus 2 equals 3 to the log base 3 of x, which is a total mess, but reduces nicely because the functions are inverses. So on the right, we just have x, while on the left, we have x plus 6 divided by x plus 2. An alternative way to think about this is that since log base 3 of x plus 6 over x plus 2 equals log base 3 of x, the two inputs, x plus 6 over x plus 2 and x, must be equal to each other because log base 3 is a one-to-one function. So now that we've simplified the logarithms using its inverse exponentiation, it remains to solve the rational equation x plus 6 divided by x plus 2 equals x. If you'd like to see the steps of this equation done out, you can click the link to the left now. Solving this rational equation, we get the solutions x equals 2 and x equals negative 3. But remember, the domain of any logarithm is only positive numbers, from 0 to infinity. So we need to check if our equation is defined at these particular values of x. For x equals 2, in our first logarithm, we have x plus 6, which is 2 plus 6, or 8, which is positive. So our logarithm is defined there. In the second logarithm in our equation, we have x plus 2, which in this case is 2 plus 2, or 4, is positive as well. So our second logarithm is defined at x equals 2 as well. And finally, in the third logarithm, we just have x, which is 2, which is positive, which means that all of our logarithms are defined when x equals 2. So x equals 2 is indeed a solution. But for x equals negative 3, in the final logarithm, we just have x, which is negative 3, which is negative, which means that log base 3 of negative 3 is undefined. And since log base 3 of negative 3 is undefined, x equals negative 3 cannot be a solution. So finally, we can conclude that the solution to our logarithmic equation is x equals 2.